So what we're looking at today is function operations. And it sticks to basically the basics of everything that we're looking at when it comes to functions. We're going to add, subtract, multiply, and divide. Okay, and again, the best I could tell, I think this is number 8. I think where we left off before spring break was number 7. I went back and double checked, so I think this should be about where we are. So, okay, and when we're doing function operations, the way they're going to set this up is they're going to show you something like this, that they're going to have f of x plus g of x. They may also have it so that it may be written like this, where it's f plus g. We'll do subtraction. And basically, and here's kind of what it is out beside these. With the f of x plus and the f of x minus, when we're doing either addition or subtraction, with either one of these two things, you're basically just combining like terms. That it's going back to some things that we've done in the past. So really, it's nothing different than what we've done before. It's just the setup is just a little bit different to kind of get you there. With multiplication, f of x times g of x. So it may look something like that, where we're doing f times g. And more than likely with multiplication, it may be this way almost every single time. Should be pretty much that you're going to be doing the full method. There might be one possibly where it might sneak in maybe just distributed property, but pretty much everything that we're doing for these, I think everything's going to be wind up being the full method. And the last one with division. With division, it's really not division, because one of the last things we were doing was synthetic division. This is not synthetic division on this part of it. That when you're having this one with the division part that's set up here, the big thing is that you're going to factor and cancel. If it's possible. Some of these you won't be able to factor and cancel. So once you basically write down the operation, that's pretty much all that you're going to do for this one. Okay, so when we're talking about function operations, that's what we're going to talk about. It's add, subtract, multiply, divide, just your 4 basic operations, but we're going to do it with functions instead of just with numbers or terms or whatever we're going to do for this part. The one other thing they're going to ask you to talk about is the domain. And basically is this. The domain for any of these functions that you have is going to be all real numbers. The one exception on this one is that you're going to exclude any denominator you have set equal to 0. Okay, so your default answer is going to be, when they talk about domain, your default answer is all real numbers. The only time you have to say anything else is that if you have a denominator, you set that equal to 0. If there is no denominator, then you have no exclusions. Okay, because sometimes when we've done some problems before, that people get a little thrown off because they're like, well, there's no denominators here. I'm like, well, that's good. If there's no denominators, then there's no exclusions that you have to worry about. It's just all real numbers. All right, so what we're going to do, just going to run through some examples and show you some different things on this one. Everything's pretty much straightforward. there's a couple of things you just have to be careful of. So I don't think that anything here is too terribly hard. It's more of just being careful and kind of running through some different things. All right, so for example one, they should give you two functions. So for this one, we'll do f of x is 2x squared plus 8. And then we'll do g of x. We'll say that's x minus 3. And the problems in the homework, they may have you go back and do all four. They may give you just a couple of them. For the first problem, we're going to do everything. We're going to do all four just so you can see all the parts of this one. For some of the other ones, we'll maybe do a couple of them. We'll maybe do we won't do everything because addition and subtraction are almost exactly the same thing when it comes to these. So a lot of times we won't do both addition and subtraction because they're really, really similar in the setup on these. All right, so for part A, we'll just go through the list on this one. We'll do f of x plus g of x. All right, so f of x is 2x squared plus 8, and g of x is x minus 3. And with addition, we said addition was easy because there's really not much else to it. You just write down what it is, and then you combine whatever you can do. In this case, the only thing you can combine like terms on would be the 8 minus 3. So that'll make that 2x squared plus x, and if we do 8 minus 3, that would be 5. Okay, now, and we're going to go ahead and all the answers we'll put it in descending order, put it in standard form, so that would be the final answer that we're looking for. And on this problem, if they ask you for a domain, you're going to start off with every answer is going to start off with all real numbers. And then if you have any denominators, then you'd come back and tell me, all right, what makes that denominator equal to 0? In this case, there's no denominator, so the answer for domain is just all real numbers. All right, for part B, we'll do subtraction. So we'll do f of x minus g of x. Okay, this is one that you have to kind of be careful of because this is one that if you're going to do minus the g of x, you actually have to put in a parentheses around that one. So it's minus the x minus 3. So that's 2x squared plus 8. And if you do, and again, you can think about this one a couple of different ways. With the minus in front, it's almost like distributive property with a -1, that it's -1 times x, and then it's -1 times -3. And most everybody will put the minus x because that's the easy one to do. The one thing that sometimes people forget is they'll forget to change that minus negative to a plus to make that a plus 3. Okay, and again, not a big deal, but it's just one of those that with subtraction, you just have to be careful. Again, it's not hard. It's just, again, just be careful. Because it's always that one little term that throws people off sometimes when they go through this one. All right, from there, do the same thing. We'll combine like terms. 2x squared is good. The minus x is good. The only thing you can combine is the 8 plus 3. So then you can make that 11. Okay, and if they ask you for domain on this one, still the same thing. It's still all real numbers. Okay, so addition, subtraction, pretty much the same thing. It's just, with subtraction, you have to change some signs, where with addition, you don't have to change any signs. And that's really the only difference of what it is. So subtraction, you're always changing the signs of the second thing, that your second function you're going to subtract. Addition, you don't have to change anything. You just combine like terms. Okay, when it comes to multiplication, there's not really anything tricky about it, because if we do f of x times g of x, well, it's pretty much what you think it would be. You write down the f of x. Now, in this case, you do want to write them both in parentheses. So it's 2x squared plus 8 times, and then just x minus 3, which again basically means we're going to do the full method here. All right, so we do 2x squared times x, and then 2x squared times 3. So 2x squared times x would be 2x to the third, and 2x squared times negative 3 would make that negative 6x squared. All right, and then we'll do the same thing with the 8, that we'll do 8 times 3. Oh, sorry, 8 times x and then 8 times 3. Okay, 8 times x is 8x. 8 times 3, which was a negative 3, would be a negative 24. All right, and this was actually kind of a weird, or I would say weird, just a unique full method, because when you get to the end, there are no like terms. So for this one, that is your final answer. Most of the time when you do the full method, usually the middle two terms, you can combine those together, but this is one of those problems where it just didn't work out that way because of the way the powers matched up. Again, if I ask you for domain, it's just all real numbers. So as long as you don't have fractions, there's nothing you have to exclude. Your answer is always going to be just all real numbers there. All right, and then the last one, we'll do division. So it's f of x divided by g of x. So it's 2x squared plus 8 divided by x minus 3. Okay, and again, with the division on this one, it's not really division. It's really more factoring in this case. It's factor and cancel. So the first thing is, as soon as you get here, the question is, see what you can factor. Well, bottom part, there's nothing. So it's x minus 3. Top part, you do have 2x squared plus 8. You can divide them both by 2. So if you divide the 2 out of both of those, that'll get you down to x squared plus 4. Even from there, there's not anything else you could do with this one. If that was x squared minus 4, you can break that up as a difference of perfect squares, that you could do x plus 2 and x minus 2. But for this one, that's as far as that one goes. So if they ask you to work on this problem, that's pretty much about all that you can do there. Okay, so that one, they may let you, if this was a problem that they were doing before, they might let you leave this answer. But to me, you factor it out as much as you can. They should let you do this answer also. And that's all you can do for this one, because there's nothing else you can cancel. So that would be it. Domain, though, that's where you actually have to do some work on this one. So it's all real numbers. But in this case, you've got to exclude x minus 3 equal to 0. Now, and the one thing is, when you're checking the domain, even if this part would have canceled back here, you always go back to the original part to check your denominator. So whatever the original denominator is, that's the part that you've got to exclude when you go into this thing. All right, and for this denominator, again, really pretty easy. X minus 3 is equal to 0. Just add 3 to both sides. So for this one, it's everything except for, we're going to exclude x equals 3. All right, and then that would be the answer that they would give you for the domain. It'll say all real numbers except for, exclude, something like that, and then they'll give you x equals 3. Okay, so there's the basics of everything. There's the add, subtract, multiply, divide. All we're going to do is look at a couple of other examples where we give you something where maybe it's a little bit different looking, something that's a little odd looking, or maybe just something even that we could, just something that might be a little bit different for whatever it is that may happen along the way here. So, all right, so let's give you something that's just a little same thing, but just a little different variety on this one. Again, we're not going to do every single one of these. We'll just give you some that will make it so that it's a little bit easier to kind of just go through some different examples on this one. All right, so let's say the f of x is 3x squared minus 11x minus 4. And let's go with g of x. Let's have that be x minus 4. All right, we'll actually do a couple of them here. We'll do f of x minus g of x first. So that would be 3x squared minus 11x minus 4. And sometimes you'll even see it when they do this. They'll put this one in parentheses to let you know that that's the f of x part. And then minus, they'll put the g of x in parentheses. Now, sometimes it's parentheses overkill, but sometimes they'll do that just to make sure that you understand that, okay, this is the f of x, and then that's the g of x that's there. All right, again, with subtraction, it's really the second part, because the first part, you're not going to change anything here. We're going to do minus the x, and then minus the negative 4, which will change that to a plus 4. Okay, and then same thing here. Go back and combine your like terms. Well, that means you can do the 11x, and technically it'd be minus a 1x. So you've got 3x squared. Minus 11 minus 1 would make that minus 12x. And with the constants at the end, you've got a minus 4 and a plus 4. That'll just go to 0. If you do 4 minus 4 or negative 4 plus 4, that still goes to 0. So that would be the answer you'd have for that one. Okay, again, they asked for a domain on this one. No fractions, so it would just be all real numbers. All right. Now, what we're going to do, let me go ahead and do a part B on this one. Is for this part, we're going to go ahead and do division. We'll do f of x divided by g of x. So that's going to be 3x squared minus 11x minus 4 over x minus 4. Okay, very first thing again for this one is you want to go ahead and get your domain out of the way. So the domain would be all real numbers, but you've got to exclude the x minus 4 equal to 0. But again, that one you just add the 4 to both sides, so that would be excluding x equals 4. Okay, so just set x minus 4 equals 0, then that we're going to leave that out. Okay, so go ahead and again, if you've got the part with the fractions where you're doing the division, go ahead and kind of get that part of it out of the way. That way, anything that happens after this, then you don't have to worry about anything else that's there. So just take the original denominator, set it equal to 0, and tell me it's all real numbers except for whatever that number is that's equal to 0. Okay, the actual solving factoring part of it is, I'm going to go to the next page here because I'm there at the bottom. If we take the 3x squared minus 11x minus 4, we're going to try to factor this part. Okay, and to do that one, this is where we had to kind of go back and brush up your factoring skills a little bit. If the first term was just x squared, we look for the factors of 4 that would equal 11. If that first term is something other than 1, then we've got to go back and multiply using the AC method. Do 3 times negative 4. So now we're doing the factors of negative 12, where the sum would equal negative 11. Okay. And if you list off all your pairs of factors, there's no way you can take 2 and 6 or 3 and 4 and get 11, so it's got to come down to the 1 and the 12. B term is negative, so we'll put that sign with a bigger number. And then if we divide a negative by a negative, it makes the other number a positive. So we're going to use x plus 1 and x minus 12. Okay, but with the AC method, because we multiplied by 3 in the beginning, we've got to go back and divide by 3 to make this thing kind of even back out. This one, you get x minus 4. This one doesn't simplify with the 1/3, so that's where we said we'd do the bottoms up, take the 3, pull it up in front of the x to make it 3x plus 1. Okay, so if we go back to that original problem that we had, that's the numerator factored out to get to this. So the final part we're going to give it a look at is doing 3x plus 1 and x minus 4. That's got to be over the x minus 4. Sorry. Okay, so this was all the work we were doing to factor the numerator. So we factored out the numerator, put that over the original part, and then hopefully that's where, again, this is where it's kind of 50-50. That earlier problem we did, it wouldn't factor. We didn't get any canceling off of it. This is one that once you factor it, now you can cancel out the x minus 4s and get that your final answer in simplified form would be 3x plus 1. Okay, so there's more kind of what the problems that you'll see that if you can factor them, that's what we're talking about, that you get to factor and cancel. Factor in numerator, you factor denominator, factor everything as much as you can, and then once you have that, anything that's in common, cancel it out, and then just tell me what you have left over. If there was something else here, let's say you canceled this one off, and there'd been like another x minus 2 out here. You wouldn't have to go back and do the full method. If this was in factored form here, you could just leave that in the factored form answer. If you had, if that was your answer and that was x minus 2, you could just leave it factored like that. You would not have to go back and do the full method and multiply those parts together. But on this one, so we're just going to leave that out. Okay. Oh, now one other thing. I'll show you this one real quick. It doesn't always have to be f of x first. For these problems, sometimes they'll do g of x minus f of x. So sometimes people automatically assume that it's always f of x first. They can do these in any order. So how they put these in here, it doesn't really matter. Sometimes they'll do f of x first, sometimes it's g of x. So don't just automatically get locked into thinking that every time that you do this one, it's always going to be 1 first. So for this one, if we do subtraction on this one, it'd be x minus 4 minus 3x squared minus 11x minus 4. All right, again, first part of it, everything is good. This one, you've got to change all the signs back here. So it's going to be a minus 3x squared minus a negative 11 will make that a plus 11, and minus negative 4 will make that a plus 4. Okay, so then we're back to the same thing. Now that you've done the subtraction and changed all the signs in the second function, now you're combining the like terms. So now we've got 1 plus 11 for 12. So you've got the negative 3x squared plus 12x. And then this one worked out kind of the same way, that we've got a negative 4 and a positive 4. So those just cancel each other out. So then that would be your final answer there. All right, and if they ask for domain on this one, it would still be all real numbers because we didn't have any fractions here. Don't know if they will, but if they did, then it would still be all real numbers. Okay, so there's something with some different options of what it may be. Again, want to show you one that had the factoring. Again, just be careful with subtraction. Again, it's not hard. It's just you've just got to be careful that whatever the second function is, you've got to change all the signs in that second function, and then you go back and add or subtract the like terms. All right, last thing I need to show you here. And this one may or may not pop up, so just in case it does. That some of the functions may look a little bit odd. So maybe we've got something like this. So f of x is equal to 2 minus x, and g of x is equal to 1 over x. All right, and again, addition, subtraction, we'll just kind of go through the whole. Addition and subtraction is almost the same thing. So for this part of it, we're going to do 1. So we'll do f of x minus g of x. Because it's basically the same answer for addition that is subtraction. There's just one sign that's going to be different. Your f of x is 2 minus x. If you do minus the 1 over x, there's really not anything that's going to be really different about this one, because once you do minus that, there's only the one term. So it's just 2 minus x minus 1 over x. Now here's the trick on this one. Here's the catch for the part on this one. If they give you something like this where we've got whole numbers and all of a sudden you've got a fraction here, they're going to ask you to eliminate the fractions over here. So we're going to say that we're going to eliminate the fractions by multiplying all the terms by the least common denominator. And again, this may not happen. It might just sneak in there every now and again, but just in case it does, if they give you a problem that's got fractions mixed in with whole numbers, this is still a good answer, but it's just not the way they want it. They want it so that when you do this part of it, that there's no fractions involved with this thing. So what we'll wind up doing is we'll take this original problem that we've got here and just go back and multiply everything by x, because basically you just take whatever denominator is that you have and multiply by that number. All right, and by doing that one, you've got x times 2, which is 2x. X times x would be an x squared. If you do x times 1 over x, the x's cancel out, and then it leaves you with the minus 1. That answer probably would be okay if we kind of stick to everything that we've been doing lately. A lot of times on these, they're going to ask for standard form or standard notation, so we go back and write it in descending order. Negative x squared plus 2x minus 1 probably would be a little bit better answer. There's nothing wrong with this one, but this one's probably just a little bit more better. It's a little bit more correct, I guess, if you want to say it that way. Now, if you go back to the original problem back here, you had 2 minus x minus 1 over x when you talk about your domain. Still going to be all real numbers. You've got to exclude, again, once you write down the original problem, this is where you take your denominators and set it equal to 0. Well, in that case, that's just x equals 0. There's no solving on that one because it's just x equals 0. So for that one, you got your domain and you got your excluded parts there. You don't have to do anything else to solve for the exclusions on that one. Okay, so either one of those two answers would be good there, and then there's what you have for your domain. Okay, and the only difference, if this had been an addition problem back up here, your domain would still be the same. The only difference is on this part is that this answer that was here that was minus the 1 over x, that would be a plus. So it's the same setup, just one sign would be different for that one, for addition. So we're not going to worry about doing addition because it's basically the same thing. Okay, I do want to show you multiplication because it's along those same lines, but just a little bit different. So we'll just make sure everybody's good with it here. So if you do f of x times g of x, that's 2 minus x times 1 over x. All right, and in this case, it is just distributive property. So it's 2 times 1 over x, which would be 2 over x. And then minus x times 1 over x. If you do x times 1 over x, well, that's where the x's cancel. I'll leave you with just a minus 1. All right, but here's where they're kind of back like we were on the other problem. That if you have this part with a fraction here, they're going to tell you to go ahead and eliminate the fractions. So we'll go ahead and x is our denominator that we have here, so we'll go ahead and multiply everything by x. So the x's would cancel, leave that with a 2. If you do x times 1, that's just minus 1x. But again, if we kind of think about putting this in like a standard form where the x goes first, that would be negative x plus 2. Again, this would still be okay with 2 minus the x, but negative x plus 2 is probably, again, just a better answer. All right, again, the setup is for domain, it's all real numbers that you start with that one. We did have the denominator here back in the original problem, but it was still just x, so we're still going to exclude x equal to 0. There's no solving on that one, so it's just x equal to 0. All right, last problem of the day. So there's multiplication. We'll show you division. And that'll be the last thing that we'll look at here. We'll do f of x divided by g of x. All right, and this is the one that looks a little bit funny because it's 2 minus x on top, which is not bad, but it's over 1 minus x. So it's over so it's got a fraction inside a fraction because you got the 1 over x inside the denominator, so it's like a double denominator almost. But here's where we're going to take you back to middle school. Anybody remember, because we did one like this earlier in the year, anybody remember what we did on this one? Kind of flashbacks to middle school? Yeah, doing the reciprocal thing, right? That's where we could keep the top fraction the same. We could change it and then flip it. So we could use our reciprocal on this one. So if we do that, that's 2 minus x times, take the reciprocal of the 1 over x and make it x over 1. But in that case, x over 1, the 1 doesn't really do anything. So really it's just 2 minus x times x. So we're just doing distributive property. So it's x times 2 for 2x, x times x for x squared. And again, if you worry about that one in descending order, just got to rearrange it and put the negative x squared first and then put the plus 2x second. Okay, so that's one where if you do the division with the fraction, it kind of works its way out because once we do the reciprocal of it with the keep change flip there, it takes the fraction away anyway and makes the answer so it's a little bit neater and nicer on this one. If you go with the main on this one, it's all real numbers. And again, if you go back to this one, normally this would be your denominator that's here, but the denominator is inside the denominator. Either way you go, it's still x equal to 0. And again, once it's set there, then that's pretty much all that you've got. So. Okay, so there's all your function operations. Again, mostly add, subtract, multiply. And division, again, is really not even division. It's really more factoring and canceling. In this case, when we did division, because of the fraction, it wound up actually being a multiplication problem.